do 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 do. What type of tree? A geometry. All right, ladies and gentlemen, with that said, notebooks, take him on out right now. All right. So, ladies and gentlemen, welcome back to another exciting day of geometry while we're in quarantine. Okay, the learning target for today is understanding the arc length formula. Okay, so, last week we kind of reviewed the basics of the circumference formula. Well, the whole purpose of reviewing the circumference formula is so that it would help us when we do the arc length formula. That's what we're working on today. Alright, so dealing with arc length, let's talk about a couple of things we'll need. First, it's really important that we know an angle of interest. Alright, so given an angle of interest, we can use that to determine this portion here. Okay? And we will need to know how big the circle is. So, from the center of the circle out, like what the radius of that circle is. And knowing the angle, knowing the radius, we will be able to devise a formula that can help us identify this guy right here. I like to think of this as the crust of the slice of pizza. It's really a portion of the perimeter of the circle. As such, this is like a section of the circumference. Alright, so today we're going to be understanding the formula, understanding the arc length formula. Okay, so again, arc length, let's see what that is. Arc length, so arc length, basically arc length is, we can think of this as the crust of a slice of pizza. Okay, so we can think of it as the crust of a slice of pizza, but in all honesty, it's actually a section of the circumference. Oh, lost it all there. Sorry about that. Okay, so we can think of this as like the crust of a slice of pizza, but it's really a section of the circumference. Okay. Now, let's talk about this formula. So in order to get this portion, we're actually going to need to think of like fractions in this case. We want to relate the arc length to the angle that we're given. So we're going to be considering the circumference in terms of angles. Alright? And when we think about this, again, we're going to be thinking about circumference or perimeter to angle. Okay, so perimeter of a circle to the angles of a circle. Now there's going to be two sections here. First one, what we want to think about is again, when we're talking about the perimeter, it's really the main thing that we're looking for is the circumference. So we think about a part over the whole will equal part over whole. And we're thinking about angles here. And here we're considering circumference or perimeter. Okay. Now, these are the concepts that we're considering. We're considering the perimeter. We want to relate that to the angle. As such, we use part of the circumference that we're looking at, arc length, divided by the whole circumference. That's going to equal part of the angle of interest that is contained within the minor arc as well as the circumference. And also we're thinking about the total amount of angles in a circle. Okay? So part over whole. Well, we're looking at arc length divided by circumference and that's going to equal, so the arc length over the circumference, and that's going to equal the angle that we're interested in, or A, over the total amount of angles of a circle. Angle A and total degrees of a circle. Okay, and this is what I mean about part over whole. Part over whole. The arc length divided by the circumference is equal to the angle of interest divided by the total number of degrees of our circle. So again, looking at this picture here, we're going to relate the arc length, which is part of the circumference, divided by the whole circumference, related to the angle of interest that we're looking at over the entire angle of the circle. Okay. So this is the last part. So this is the formula right here. Formula. We're going to have arc length, let's just say AL, over circumference, C, which is equal to A over 360. Well, realize I just want to have my arc length. So to get rid of this guy, we're going to have to multiply both sides by C. C's cancel out, and we have the arc length. Arc length is equal to the angle times circumference divided by 360. However, we know the formula for the circumference, so that's really just A times 2 pi r over 360. Okay, let's see how this is done. First, let's draw ourselves a nice circle. there we go. Example 1. Here's the center of the circle. And let's say that this is 60 degrees. Okay. And just for fun, we'll say that this is 5 feet. Okay, we have a circle with a radius of 5 feet, and we would like to figure out what this guy here is. So, the formula again. First thing we do, arc length is equal to, you can even zoom in a little bit, arc length is equal to the angle of interest times 2 pi r all over 360. Okay, so first thing we want to do, 1 steps. Write down formula. Okay. Once we've done that, plug things in. Okay, we know all the pieces of the puzzle right now, so plug in. We have our A. A is 60, so we have 60. We have our 2. We have the radius is 5. Leave the pi on the side. All over 360. 3. Reduce. Now you could plug this all into your calculator, or you could just do the old-fashioned way. Notice that 10 can go into both of them. So this reduced down to 6 over 36. Well, 6 goes into 36 6 times. 2 in the top, 6 in the bottom. 2 goes into itself 1 time, 2 goes into 6 3 times. And then, my friends, is that. Nothing else to reduce. So 5 pi over 3. 5 and pi were left in the numerator. The denominator, everything else was cancelled out except for the 3. And we could leave this with just saying feet on the side. Ladies and gentlemen, we are done. And this is the arc length. Now, if we want to actually figure out what the exact value is, we can plug that into a calculator.